Imagine for a second that it's 3:00 a.m.
Oh, the worst time.
Right. Your phone is sitting on the nightstand, and it's completely silent. It doesn't buzz, the screen doesn't light up, you just sleep.
Which is, kind of a miracle for anyone on call.
Exactly. I mean, contrast that with the classic adrenaline-spiking reality that anyone who has ever been on a DevOps or, SRE rotation knows all too well.
Oh, yeah. The phone, right.
And not just detected it, but investigated the root cause and dropped a complete mitigation plan right into your team's Slack channel before your REM cycle was even interrupted.
I mean, it sounds like a utopian fantasy for anyone who has ever carried a pager. But we are moving from a world where engineers have to manually hunt for needles in a haystack to a world where the system just, hands you the needle.
Hands you the needle along with a thread and asks if you'd like it sewn up.
Exactly.
Well, welcome to the Deep Dive. Today is March 19, 2026, and we're looking at the latest AWS prescriptive guidance alongside the massive data dumps from the recent reInvent conferences.
There's a lot of data there.
So much data. But that scenario we just described, it isn't science fiction anymore. Today, we're figuring out how autonomous cloud operations are actually killing the midnight pager.
Which is a huge deal.
It is. We are looking at how technologies like CloudWatch anomaly detection, Amazon Q, and the new AWS DevOps agent are fundamentally changing incident response.
Yeah, the goal here is to really cut through the AIOps buzzwords.
Right, because there are a lot of them.
Yeah.
We want to give you a real operational understanding of how this actually works in practice.
Because to grasp how these autonomous agents function, we have to start at the foundation of the data collection itself.
Okay, let's unpack this. Because the underlying monitoring has evolved, right?
Yeah.
We've moved from static alerts into dynamic reasoning.
Yes, exactly.
And I was watching one of the reInvent keynotes, and they used a Formula One pit stop analogy that really clicked for me.
Oh, that's the perfect lens for this. What's fascinating here is if you look at an old F1 pit stop from, say, the 1950s, you had a crew doing visual inspections.
Right, just looking at the car.
Yeah. They relied on humans shouting when a tire looked worn or manually checking engine temps with analog gauges. It was entirely reactive.
Which is basically the old way of IT monitoring.
Exactly.
Right.
You set a static threshold, you tell the system to send a page anytime CPU usage hits 80%.
It's just a blunt instrument.
Very blunt. But a modern F1 pit stop doesn't wait for visual confirmation. It uses sensors to stream predictive telemetry.
So it's telling the crew a specific tire will fail in exactly 3 laps.
Right, based on historical friction data and the current track temperature.
So CloudWatch ML is essentially doing that for cloud infrastructure.
Right.
It's not just looking at the tire right now, it's looking at the historical frictions.
Exactly. It acts as the machine learning brain of your operations, and it does that by establishing dynamic baseline.
Okay, dynamic baselines, meaning it learns what's normal for you.
Right. Instead of relying on a human to guess what a safe threshold should be, CloudWatch uses unsupervised machine learning algorithms to analyze your historical metric patterns.
So it learns your specific seasonality.
Yes. It understands that having 1,000 concurrent video calls hitting your media servers is completely normal at 2:00 p.m. on a Tuesday.
Sure.
But if that exact same load hits at 3:00 a.m. on a Sunday, it recognizes that as a highly abnormal event.
Whereas a static alert would either miss the Sunday spike completely because the threshold was permanently set too high,
Or it would falsely trigger on Tuesday because it was set too low. Dynamic baselines eliminate that noise entirely.
Okay, I understand Amazon has to process a lot of data to train a model to be that highly contextual, but,
Right.
and I'm curious about the sources here. What kind of scale are we actually talking about behind the scenes?
Honestly, it is hard to wrap your head around. Internally, to build these baselines, Amazon is processing 17 exabytes of logs.
Wait, 17 exabytes?
Exabytes, yeah. And 32 quadrillion metric observations every single month.
Wow, that's, quadrillion.
It's an unimaginably vast pool of operational telemetry. And it uses that baseline to trigger what AWS calls a CloudWatch investigation.
Okay, so when a metric deviates from its predicted band, it doesn't just fire off a blind alert.
No. It automatically starts pulling in related traces, AWS health data, and CloudTrail configuration changes.
So it's doing the initial triage for you. But I'm curious how it actually structures that investigation, though.
Yeah.
Because it's one thing to dump a bunch of logs into a folder.
Right.
It's another to actually make sense of them.
Well, this is where AWS baked their internal correction of errors, or COE methodology, directly into the tool. It systematically uses the 5 whys analysis.
The 5 whys. Okay, walk me through that. Let's say your symptom is high API latency.
Sure. So a human would normally have to manually query to find out why. The AI automatically does it. It asks, why is the API slow? Because the Lambda function is timing out.
Okay.
Why is it timing out? Because it's waiting on a DynamoDB table. Why is the table slow? Because a partition key is hot.
Right.
Why is it hot? Because a recent deployment changed the query structure. The system drills down through those symptoms instantly to find the systemic root cause.
That is incredible. And the sources mentioned the Kindle team internally at Amazon adopted this workflow, right?
Yeah, and they reported an 80% reduction in the time it took to investigate incidents.
An 80% reduction just from the system gathering and correlating the evidence. That's massive. But gathering all this context-rich data is really just step one.
Exactly.
Step two is how human engineers actually interact with it during a crisis. Because in 2026, you aren't digging through endless spreadsheets
No,
or manually writing complex query languages. You are talking to Amazon Q.
Right. Amazon Q has really become the conversational interface for this entire observability stack.
Okay, here's where it gets really interesting, but I have to push back here for a second.
Okay, go for it.
Because I know what some of you listening are thinking. Every single company has tried to shove an AI chatbot into their product over the last few years.
True.
Isn't Amazon Q just a glorified chatbot? I mean, when my site is down, I don't need an LLM spitting out generic links to AWS documentation.
Right, you need answers.
I need to fix the server.
Yeah.
How does this actually help an engineer who is sweating through a live Severity 1 outage?
This raises an important question, and it's a very valid skepticism, especially given those early clunky iterations of AI assistants we all suffered through. But Amazon Q Developer is fundamentally different because it is deeply context-aware of your specific AWS environment. It isn't just searching documentation.
So it actually sees your setup.
Yes, it has the same IAM permissions as the user interacting with it. That means it can look directly at your resources.
Okay, give me an example.
Say you have a console error, like a VPC reachability issue, where a web server suddenly can't talk to a database backend.
A classic nightmare.
Exactly. Q performs a one-click diagnosis. It doesn't give you a tutorial on how VPCs work. It reads your specific security groups, parses your specific routing tables, and tells you, quote, Rule 44 on subnet B was modified 2 minutes ago and is now blocking port 5432.
Oh, wow. So it's literally acting like a senior engineer looking over your shoulder at the actual configuration.
Exactly. And we've seen this have a huge impact across the broader software development lifecycle, too, not just in incident response.
Yeah, I know Gartner recently highlighted Q developers' impact in their industry reports.
The efficiency gains in daily development are just striking. The Gartner reports highlighted a startup called Namu that integrated Q Developer and reduced their overall development time by 30%.
30%? That's huge for a startup.
And in the enterprise space, Availity, which is a healthcare tech company, saw a 75% faster release review time.
Wow.
Yeah. The AI assists with writing code, refactoring legacy apps, upgrading software versions. But honestly, its most critical feature during an active incident is the ChatOps integration.
Right, because Amazon Q lives natively inside Slack and Microsoft Teams.
Yes.
Which is the ultimate context switching killer.
Right.
During an outage, context switching is the absolute enemy of speed. You have engineers looking at logs in an incognito window, metrics in a Datadog tab.
Frantically typing in Slack.
Yeah, trying to update stakeholders who are panicking. It's too much.
Q acts as the centralized bridge. When that CloudWatch investigation we talked about finishes its 5 whys analysis, Q pulls the anomaly graphs, the relevant log snippets, and the root cause hypotheses directly into the Slack channel.
So everyone is on the same page.
The entire response team sees the exact same data at the exact same time in the place where they are already communicating. Nobody is asking for a link to the dashboard.
Having a conversational co-pilot handing you the right maps and pointing out the hazards is great. But a co-pilot still requires a human in the pilot's seat to actually fly the plane.
Which brings us to the next level.
Exactly, the most mind-bending part of our deep dive. What happens when we hand the wheel over entirely to the AI? That is where the AWS DevOps agent comes in.
Right. This is the transition from AI as a passive assistant to AI as an active, autonomous operator.
The technical papers from the sources describe the DevOps agent's multi-agent architecture like a lead detective at a major crime scene.
That's a great way to think about it.
The lead detective, the main agent, shows up, surveys the overall situation, but doesn't do all the manual labor itself. It starts delegating to sub-agents.
It assigns tasks.
Yeah. It tells one, go parse and compress this massive 10 GB log file. It tells another, trace this specific request path through our microservices. It orchestrates the investigation.
AWS categorizes this as a frontier agent.
A frontier agent.
Yeah. A standard conversational agent, like we just discussed with Q, requires a prompt. It waits for you to ask a question.
Right.
A frontier agent works completely autonomously, running in a continuous loop. It can grind away for hours or even days on a single complex problem without needing a human to hit next.
And its primary capability is correlating real-time telemetry data with CI/CD deployment history, which answers the most critical question in any troubleshooting scenario. What changed?
Because systems rarely just break on their own. Usually somebody deployed something.
Always. Let's walk through the example they gave at reInvent because this really clarified it for me. Imagine your application suddenly experiences a massive database latency spike. The P95 latency jumps over 500 milliseconds.
Right, so a traditional alert fires.
Exactly.
In a standard setup, an engineer logs in, confirms the latency, checks the database metrics, realizes queries are scanning too many rows, and then starts hunting through recent code commits to figure out why. That could easily take an hour.
But with the DevOps agent, it gets paged instead of the human.
Yes.
It automatically looks at the CloudWatch metrics and confirms the latency. Then it actively reaches outside of the AWS ecosystem. It checks your GitHub or GitLab repository.
And it's not just doing a keyword search for database.
Right, it uses semantic reasoning to read the Git diffs. It realizes that a developer just pushed an update that accidentally removed a critical database index.
Which happens all the time.
The agent correlates the timestamp of that dropped index with the exact second the latency spiked. It explains the root cause, and then, this is the crazy part, generates a pull request with the code to restore the index.
You touched on a crucial capability there, though, reaching outside of AWS. That is made possible by a framework called the Model Context Protocol, or MCP.
Let's hover on MCP for a second.
Yeah.
Because very few large organizations use only AWS native tools for their observability. They might use Datadog for application performance, Splunk for their security logs, maybe New Relic for UX monitoring.
Oh, absolutely.
And historically, AI tools were walled gardens.
They were completely siloed. And AI built by AWS could only read AWS data. MCP changes that. You can think of it like USB-C for observability tools.
USB-C, I like that.
It is an open, standardized API wrapper. When the AWS DevOps agent decides it needs to look at a Datadog dashboard to confirm a hypothesis, MCP translates that intent into the exact, secure Datadog API call.
Wow.
It authenticates it and returns the JSON data in a format the LLM can instantly understand. It breaks down the silos so the AI can reason across your entire messy real-world tech stack without requiring engineers to build hundreds of custom plugins.
So what does this all mean? Having an AI pull logs from Splunk or Datadog into Slack still doesn't fully explain the massive ROI we're seeing in these industry reports.
If we connect this to the bigger picture.
Yeah, if the AI is just fetching data faster, where are companies actually saving all this money? How does this change the daily life of an SRE team?
To understand the business value, we really have to look at the anatomy of mean time to resolution, MTTR. In a typical Priority 1 incident, the resolution process is heavily front-loaded with wasted time. The incident response platform Incident.io published data showing that in a standard manual response, the first 12 minutes are wasted entirely on coordination overhead.
Coordination overhead. So that's the 12 minutes of just trying to get the right people onto a Zoom call.
Exactly. Finding out who is actually on a call.
Pasting links to dashboards, asking what did you see when it went down.
Yeah.
And just trying to establish a shared reality.
And those 12 minutes add absolutely zero diagnostic value.
None.
AIOps platforms entirely eliminate that coordination waste. Because the context is gathered, the third-party logs are translated via MCP, and the hypotheses are generated before the human even looks at the screen.
So the team basically starts at minute 13.
Exactly. They start with answers, not questions.
The financial math on that efficiency is staggering. AWS prescriptive guidance laid out a specific scenario in the sources. If the autonomous agent can prevent 80% of major incidents from escalating, say, it catches 10 incidents a year that would have cost the company $10,000 each in downtime.
Right.
That's $80,000 saved purely on prevention. When you measure that against the compute cost of running the agent, you're looking at an ROI exceeding 11,167%.
It's incredible, and we see this reflected clearly in real-world case studies. Take Agoda, the digital travel platform.
Oh yeah, they had a huge migration.
They implemented AI operations during a massive, complex cloud migration. Previously, generating a comprehensive incident report after an outage, piecing together the timeline, the logs, the root cause, took 7 hours of manual engineering time.
7 hours just for the post-mortem report.
Yes, but with AI agents, they reduced that reporting time to just 30 minutes.
That is wild.
And that efficiency gain led directly to a 47% reduction in missed service level objectives.
There was also the Valvoline case study that stood out to me. They applied these multi-agent workflows to their security operations center. They let the AI handle 100% of their Tier 1 security alerts.
100%. They automated the tedious, repetitive investigations, things like tracing basic phishing workflows or verifying routine access requests.
Stuff that burns analysts out.
Exactly. By handing that to the agent, Valvoline saved 7 hours of analyst time every single day.
So that is an entire full-time engineer freed up to do proactive threat hunting and architectural improvement rather than just clicking resolve on endless false alarms.
It changes the whole dynamic of the team.
I love the idea of shifting the culture from reactive firefighting to proactive building.
Yeah.
But, and I've got to ask, that's the safety question.
Okay, lay it on me.
It's the elephant in the room that I know is keeping infrastructure managers awake at night. We've all seen large language models hallucinate.
Oh, sure.
We've seen them confidently invent facts or write really bad code. How do you put guardrails on this? How do you ensure your shiny new autonomous engineer doesn't autonomously delete your entire production database because of a bad inference?
It is the single most critical question when moving to autonomous operations.
Yeah.
You absolutely cannot just hand the keys to the kingdom to an LLM and hope for the best.
Right.
The AWS best practices lay out a very strict step-by-step roadmap for safe AI ops adoption, and it relies heavily on a concept called agent spaces.
Agent spaces.
Okay.
So they basically act as a digital sandbox for the AI.
Essentially, yes.
Yeah.
You use IAM policies to define strict operational boundaries. The rule of thumb is to treat the AI agent exactly like you would a brand new junior human engineer.
Okay, I like that analogy.
You give the agent broad read access. It needs to look at logs, metrics, and traces across your entire environment to accurately diagnose issues.
Sure, it needs to see what's broken.
But you require a strict human-in-the-loop approval gate for any write or remediation actions.
Oh.
So the agent can use MCP to read the GitHub commit, it can write the scripts to fix the missing database index, and it can stage the pull request. But a human must physically click approve before that code ever touches a production server.
So it's guided autonomy. The agent builds the plan, but you sign off on it.
Precisely.
I also noticed the prescriptive guidance pushes for a major shift in how we actually alert the AI in the first place, specifically moving to SLO-based alerting.
This requires a vital change in engineering mindset. We have spent the last decade building alarms for the engine temperature instead of asking if the car is actually moving.
Right.
If you feed an AI agent thousands of useless alerts about CPU spikes that don't actually affect the application, the agent will waste compute cycles chasing ghosts and potentially make bad decisions. You have to stop alerting on infrastructure metrics and start alerting on user-impacting business metrics.
Give me an example of the engine temperature versus the moving car in a cloud environment.
Okay, so instead of telling the AI, wake up and investigate if server CPU goes over 80%, you tell the AI, investigate if the shopping cart checkout latency goes over 2 seconds.
Oh, I see.
The AI doesn't care if a CPU spikes to 99%, it only cares if the customer's cart just crashed. You give the AI an error budget tied to that checkout latency. This ensures the autonomous agent is only acting when there is a true risk to the business.
Aligning the AI with the business goal rather than a hardware threshold makes total sense. And before you even let it loose on those business goals, the sources say teams are using evil frameworks to test the AI.
Yeah, you never test an AI agent in production. Evil frameworks are essentially automated testing pipelines, but built specifically for an AI's reasoning abilities.
Okay, how does that work?
Teams run the agent in isolated sandbox environments. They intentionally break things in the sandbox, drop a table, sever network connection, and measure the agent's prediction acceptance rate.
So how often did it find the right root cause?
Exactly. How often was its proposed fix safe and effective? You only promote the agent to handle real production alerts when those metrics meet your organization's specific trust threshold.
Trust is earned.
Trust is earned through verified performance.
You put the AI through a rigorous technical interview and a probationary period before you hire it for the on-call shift.
That's exactly what it is.
Which brings us full circle. We've gone from CloudWatch, using dynamic ML baselines to automatically find anomalies and package them into contextual investigations.
Yep.
We've seen how Amazon Q acts as the conversational bridge, bringing those complex insights directly into Slack so humans can collaborate without losing context.
No more dashboard hunting.
Exactly. And we explored the bleeding edge with the AWS DevOps agent, an autonomous entity that securely reads data across native and third-party tools using the Model Context Protocol, allowing it to act as a 24/7 incident commander.
We have officially transitioned from the dashboard era, where engineers had to visually interpret raw data, into the reasoning era, where the system does the heavy lifting of correlation, translation, and diagnosis.
And the real-world impact for you, listening to this deep dive, it means less time caught in the drudgery of firefighting. It means less time spent coordinating on incident calls and more time innovating, building, and actually sleeping through the night.
Which is the dream.
It really is. But it does leave us with one final lingering question to think about. As these AI agents take over the undifferentiated heavy lifting of troubleshooting, as they become the ones digging through the Git diffs and finding the broken code, will the next generation of DevOps engineers eventually lose the fundamental muscle memory of debugging a server manually? Or will the role simply evolve, turning tomorrow's engineers into AI managers who govern and orchestrate a vast workforce of autonomous digital agents?